All right, today we're doing something a little different. We're not just going to talk about physics, we're going to get our hands dirty, conceptually speaking, because we have a blueprint, a literal set of instructions for building one of the most fundamental pieces of our reality. So, let's dive into a recipe for a fermion. So, here's our plan. We're going to tackle this build in 5 stages. First, we'll head to the fermion frontier to really understand the mystery we're up against. Then, we'll look at the recipe itself. After that, we actually start building. First the outer shell, this carrier ball, then we'll engineer its crazy internal engine of spin, and finally we'll see how this tiny machine, creates the actual properties of matter. Okay, so let's start at the very beginning, the fermion frontier. Why do we even need a recipe for a particle like an electron? What is this big fundamental mystery at the heart of matter that we're even trying to solve here?
Well, you gotta understand the ambition here is massive. This isn't just about figuring out one little particle. The idea is that if we can crack the physical structure of fermions, things like electrons and quarks, that could be the key to unlocking a complete picture of, well, everything.
And this right here, this is the core of the problem. You see, modern physics is absolutely brilliant at predicting what fermions do. The math works perfectly. But if you really pin a physicist down and ask, okay, but what is an electron? What's it physically made of? The answer is, well, it's kind of abstract. It's basically a mathematical point in space that has properties. It's a description, not a physical object. And that right there leads us to the wild idea we're exploring today. What if we just flip our whole perspective? What if a particle isn't some abstract point at all, but an actual, physical, tiny, twisting machine built out of the very fabric of reality itself? So, if a particle is a machine, how in the world do you build one? Well, this section is our architectural blueprint. We're going to lay out the step-by-step instructions for how you might just construct reality. The recipe itself is surprisingly straightforward, at least on the surface. First up, you start with a 3-dimensional elastic fabric. Think of it as the very substrate of space. Next, you use some very specific math to give that fabric a shape. Then, you form that fabric into these little localized resonating spheres. And finally, you engineer a very, very specific twisting motion inside those spheres. Now, for this entire construction project, there is one giant, unbreakable rule. You can stretch this fabric of reality, you can twist it, you can bend it all you want, but you can never tear it or tie it into a knot. It has to remain a single, continuous, unbroken whole. No exceptions. All right, time for phase 1 of the actual build. We're going to construct the container, the housing for our little fermion machine. This container has a name, a resonance carrier ball, or RCB, and this is so important to get. This isn't a separate little marble floating in space. No, it is a localized shape of space. It's a tiny, balled-up, vibrating piece of the universe's own fabric. Now take a look at the blueprint. You'll notice right away it's not a perfect sphere. There's this unique axis that runs from a north pole to a south pole, and at one end you see that point where the fabric of space is sort of sucked in. This broken symmetry is absolutely crucial. It's what gives the machine a direction and, allows it to spin. And here, wow, you can see what happens when we go from that simple 2D blueprint to a full 3D reality. This is what that little knot of fabric might actually look like. It's not some smooth, simple marble. It's an incredibly intricate, dynamic, vibrating structure. It's a real piece of machinery. Okay, so we have our container. Now for the real magic, the engine that goes inside. This is the part that gives the fermion its most famous and, frankly, most mysterious property. So to understand the motion inside the RCB, there's this fantastic analogy, the belt trick. I'm sure you've tried this. If you hold a belt, twist one end 360 degrees, and try to buckle it, it's all tangled up, right? But there's a really clever way to rotate something continuously without that happening. And this is how it works. Inside our RCB, a central point of the fabric is just spinning continuously. But the fabric that's connected all around it performs this incredibly complex dance, this twisting and untwisting maneuver. And that dance is what allows the center to keep spinning forever without the whole structure getting hopelessly tangled up on itself. And this is the absolute kicker. This reveals the most profound, the most mind-bending feature of this entire model. For the surrounding fabric to get back to its original untwisted state, the center can't just rotate 360 degrees. It has to make 2 full rotations, 720 degrees. That is the bizarre secret of the belt trick.
So, we've done it. We've built our machine. We've got the shell, we've got the engine inside. So what? Let's turn it on and see what it actually does. This is the grand payoff, where our little model connects directly to the physics we see in the real world. And this brings us to what is maybe the single most important takeaway of this whole thing. In a model like this, properties we take for granted, like spin, mass, and charge, they're not fundamental things that are just there. They are emergent. They're the direct physical result of the geometry and the motion of this tiny machine we just built. This table just lays it all out, plain and simple. It's the big aha moment. That crazy 720-degree turn from the belt trick, well, that is what we measure as spin 1/2, the defining property of every fermion. The sheer volume of fabric it took to build the machine, that's what our instruments perceive as mass. And those vibrations on the surface of the carrier ball, yep, that's what we call electric charge. It all just clicks into place.
And so this leaves us with this one final, absolutely mind-bending thought. What if the universe isn't made of all these separate little particles and forces? What if, instead, it's just a single, continuous fabric? And everything we see, everything we are, is just that one fabric twisting itself into the grand, complex machinery of reality.